Today we are going to be talking about multiplication and division of integers. This will be the first part of a two-part series. Our focus today is going to be multiplication, but we're including division in the title because the rules for the two are the same, and so the same rules will apply when we look at our division. The rules for multiplying and dividing integers are the same. First, when multiplying or dividing two positives, the answer is going to be positive. Second, when multiplying or dividing two negatives, the answer is also positive. Third, when multiplying or dividing a negative and a positive, the answer or result is negative. Let's take a look at a couple of examples for each of these different scenarios. First, when we have two positives, it's just like you've been doing since 3rd or 4th grade. We could have 3 times 2, both are positive, equals a positive 6. Or 6 divided by 2 equals a positive 3. Next, when we have two negatives, negative 3 multiplied by negative 2, it's going to equal a positive 6. If we have negative 6 divided by negative 2, our answer or result will be a positive 3. Finally, when we have a positive 3 and we multiply that by a negative 2, our result is a negative 6. And when we have a negative 6 divided by a positive 2, our result is a negative 3. So, for the first rule, it's just like you've been doing for a long time since elementary school, where we are multiplying two positives or dividing two positives, and every time we get a positive answer. Our second rule, when we have two negatives, we also will end up with a positive answer. And our third rule, when we have a negative and a positive, or a positive and a negative that we are multiplying or dividing by, our result will be negative. These are the rules, but why do they work? Let's start with multiplication. In elementary school, you began to multiply by using repeated addition. The first factor told you how many sets, while the second factor told you how many in each set. Let's use the same concept to see how 3 multiplied by negative 4 works. 3 multiplied by negative 4 means positive 3 sets. The positive 3 here is what we can think of as our repeated addition. Let's use integer tiles to illustrate this. I will begin with an empty box. This empty box represents 0, or our starting point. Now I need 3 sets of negative 4. For this video, I'm going to use red as my negative, and I will later use yellow as my positive. So I have my 3 sets of negative 4, and I need to move these into my box because I'm adding something to the box. I am adding each of these sets to make my whole. Once I have all 3 sets added to my 0, I find out that it is equivalent to or equals negative 12. You can see that I have 12 little red squares, negative squares, in my box. Now let's look at the same problem on a number line. I'm going to start at 0. My sets are of negative 4, so I will make jumps on the number line that are 4 long, and they're going in the negative direction. I'm going to make 3 of these jumps for my 3 sets. Remember that a positive 3 is repeated addition, so I'm adding -4 3 times. The result is the final resting spot, which we can see is -12. Now let's look at an expression with 2 negatives that we're multiplying. Let's use -2 times -3 and see what happens. If the +3 or the +3 in our last problem was repeated addition, the -2 here is repeated subtraction. So -2 sets of -3 means 2 sets of 3 less than 0, or to remove 2 sets of -3 from 0. Again, I want to use integer cubes to illustrate the concept. I begin with an empty box, just like I did with the example that involved the positive and the negative, because I'm always starting at 0. That empty box, once again, represents 0. I want to remove 2 sets of -3 from 0, so before I can do that, I need to put something in the box while still keeping the value at 0. This is where the additive inverse comes in. The additive inverse property tells me that a number and its opposite will make 0. That lets me put 6 positive and 6 negative counters in the box. I need a little bit bigger box to make them fit, so I'm just redrawing my box down here so that I can have all my counters fit in the box. Now I have my counters in the box, but my box still equals 0 because each set of counters here, the positive and the negative, cancel each other out according to the additive inverse. So the value of the box still equals 0. Now I can remove 2 sets, or my -2, of the -3. What do I have left? I have 6 positive counters. So positive 6 is my result for -2 multiplied by -3. The number line can illustrate this as well. I start with 0 on the number line, and I know I need to be able to remove something, so I need to get my -3's on here while still keeping the value at 0. If I were to take and put my -3's on the negative side of 0, I would end up with -6. And -6 and the two negatives 3's up there do not equal 0 when we put them together. So I don't want to do this. My other option is to put them on the positive side. Since they are negative, I still want my arrow to go in the negative direction. I will start at 3 and draw my set back towards 0. Then I need 3 more for my second set. So I start at 6 and put in my second set. Now, since I have a positive 6 and those two -3's, really they're canceling each other out. To make this a little bit more clear, I'm going to go ahead and put a positive 6 in here to illustrate the point. Now I can see on my number line that my positive 6 and my two -3's are going to cancel each other out because of the additive inverse and keep my value at 0. Now I'm ready to remove my 2 sets in order to find my result. So I take out my -3 and I take out my other set of -3. What am I left with? My result is my positive 6 that I have remaining. That positive 6, you'll see, lines up with the positive 6 on our number line. So hopefully using the integer cubes and the number lines, we're able to help illustrate for you why the rules for multiplying integers work. Remember, a positive multiplied by a positive equals a positive. A negative multiplied by a negative equals a positive. And a positive multiplied by a negative or a negative by a positive equals a negative. In our next video, we will examine why these same rules work with dividing integers.